what's on my screen. Right now I'm showing the title slide for a PowerPoint presentation. Janine, can you see that? Okay, and then for those of you who use Stata a lot, you know, multiple windows open at one time. Can you now see the do file and the result pane for Stata?
Yes.
Awesome. So we are off to a good start then. Again, like Janine said, thanks for that welcome. My name is Merriah Croston, and I'll be talking about using Stata to create customized tables. So there are three key commands of interest. We have the table command, we have the e-table command, and then we have collect. Collect is actually a system of commands and subcommands upon which table and e-table are built. And it allows additional flexibility outside of what table and e-table offer. For today's workshop, I'll be focusing on the e-table command for a few different reasons. The e-table command is useful for collecting and displaying the results of regression analysis. So whether that's linear regression, generalized linear modeling, e-table, E stands for estimate. The table command, which we're not going over today, is useful for collecting and displaying the results of descriptive analysis, whether that's your single variable descriptive analysis or you're stratifying your descriptive analysis. That's what table is useful for. We'll focus on e-table primarily because most of you, if you're Brown School students, should have been exposed to at least linear modeling by now, so you should be familiar with that output in the pane of copying and pasting your results from Stata to your designated table shell. But also, if you can approach e-table, if you can use e-table and make use of the options provided within that command, table is like a piece of cake. So we'll jump in and start with e-table. We'll talk about formatting regression tables. We'll also get into formatting side-by-side regression tables. And then I'll give you a sneak peek at how we can further use collect subcommands to further customize our tables. So the e-table command and the new collect system are available in Stata 17. So if you haven't downloaded or if you haven't upgraded Stata to Stata 17, you might want to do that now if you're interested in e-table. You can, with the do file that Janine linked to the chat, you can follow along with some minor alterations. But if you can't, no worries. I'll be showing what I'm doing, walking through the code and showing the results. So it's not necessary, but if you'd like to, you definitely need Stata 17 in the do file that I provided. We'll start by running a regression model. So we're using e-table again. We're using some data that's available through Stata. It's fictitious fitness data, but we're able to access that through the web use command, and a few variables are available in that fitness data set. And then we'll run a very simple regression model. This is as simple as it gets, right? So we're regressing this variable hours, age on hours, and we'll store our estimates. So let's do that quickly, and I'll talk more about where we're going from here. So we'll import our data, and we have our results window to the right. We have the do file that we're working in to the left, and you see now within our environment, within this session, we've imported this fictitious fitness data set, and there are just a few variables that are available. We have age, smoke, which is a dummy variable, single, dummy for not married, that's interesting language, distance, commute, hours worked daily, and hours exercised daily. The dependent variable that we're interested here is the number of hours exercised daily, and we are examining the independent variable age, which is a continuous variable. So we'll run that model, and a shortcut, if you're not familiar, is Control D to run the line that you have highlighted. And to the right in our results pane, we now see the classic display for linear regression in Stata. This is not typically how we would like to display our results for the purposes of homework, submitting our homework, or certainly not for publication purposes, but we have all of the information we need here. We have our coefficient statistics, we have our model statistics at the top. We will store that information now for later use via the eTable command. And so where are we going from here? This is where we are. This is the display, the layout that we have. But how do we get from that to this? A table that you could submit for publication purposes, I think certainly would suffice for your homework assignments. And how do we do that in less than 10 lines of code? One of those lines is very long, but less than 10 lines of code, which is really exciting to me because when I was primarily using Stata, I was copying and pasting my numbers from the results pane to my table shell. And anyone who's done that knows that one, that is time consuming. And then you might involve someone else in checking your copying and paste job, right? So even more time, two humans involved. And also it's subject to human error. So we are gaining efficiency here and we're cutting down on human error in less than 10 lines of code. But we will get there slowly but surely. So we'll build our code as we go along. How exactly are we getting there? So what's baked into that arrow that I showed on the last slide? We're going to add and style a title and footnote. We are going to learn how to export our table. We will export to Excel, but you can export to Word, HTML, LaTeX. We will reorder coefficients or determine which coefficients to keep or drop. We will add and style our coefficient statistics, add and style our model statistics, place regression results side by side, because what you were seeing were the results for 4 separate models. They happen to be hierarchical models. We'll talk about that. We will use variable labels and factor labels. We'll add stars, and then we'll use additional commands and this collect system to further customize our table. So that's how we get from what's on the left to what's on the right. We can add and style the title and the footnote. And so I've added a lot of text here just so that you have it for later reference. But what I'm communicating here is that you can simply add with these command options a title, a string that will be used for the title, as well as a note. You can add multiple notes. They'll be placed on separate lines. You can only add one title. We can also style our titles and our notes. We can style the font in various ways, size, color, whether we use bold text, italicized text, strike it out. We can also use shading, which isn't so useful for most of our purposes here, but you can shade the foreground, the background. You can add a pattern to your title or your note. There's a lot of flexibility here. So we'll do a bit of that today and just take a look at what the capabilities are in styling the titles and the notes in eTable. So we have our eTable command here to the left at the top of our code. So you see a chunk of code here, and we'll run it after I go over some of the key elements. We'll add a title. And so all of these command options are appended to the command after a comma. So you see eTable, comma, and then a set of command options, which are separated by a space, no comma. So this will result in one very long line of code by the end of this session. So we're adding our title, applied linear modeling of hours, exercise daily. We are styling that title. The font is Calibri, the size is 12. We're using the color chocolate because although we would by default use black, we'd like to see that we're able to style this title in various ways. So we can see that something happened. If we use black, we won't see that, we've actually enacted or applied this color option. Variant, normal. So variant corresponds to the casing of our text, and we will place that text in bold font. We can add a note. This is a footnote, just to know that it's there, and we can also style the footnote. If you happen to have questions as we go along, feel free to call them out. If we don't reach the end of this training, that's fine. The way I've designed this PowerPoint presentation and the do file that Janine has shared with you is that it can be self-guided. So you can walk yourself through the rest with ease. Okay, so let's go to our do file now and run that code. First, we'll just run eTable because we haven't taken a look at that. Like, what's the basic eTable look like in Stata? So the basic eTable includes, by default, the beta values, the standard error of those beta values for all variables that are in the model, so our intercept and age, which have been included in the model, and the header for our coefficient statistics corresponds to our DV, our dependent variable of interest, and then we display the number of observations. So a very, very simple table here to start with. We'll add a title and a footnote to this. So now we see our title and we see our footnote. We haven't exported this at all yet. And now we'll style the title and the footnote. You can't see that in the results pane of the do file, or the results pane of Stata, but if we export this table, we can see that these styling options have been applied. So I've added this line of code here, which I'll talk a bit about next, which is export. I'm exporting to an Excel workbook, which is located in this folder. I'm modifying it, so if there's a pre-existing workbook that I'd like to add a spreadsheet to, I can add that option to modify, and then I've defined the name of the spreadsheet that I'd like my results to export to and replace if that spreadsheet is pre-existing. So let's take a look at that. So we see our results here in the LM1 spreadsheet, and we see that we have successfully applied options. Now, this doesn't really look like chocolate to me. It looks more like burnt orange, but we have changed the color of our title and of our footnote. So we can see those styling options, and the title is in bold, which is a little more difficult to see given this font and the color, but it is in bold font. Okay, so I got a bit ahead of myself. So exporting the table, I wanted to talk about this up front because we'll be toggling back and forth between the do file or results pane and checking that the stylings we've applied have actually, that the styles we are using have actually been applied. So there are various options when exporting. As I mentioned earlier, you can export to Excel, Word, HTML, text. You can replace a pre-existing workbook. If we're talking about Excel, you can modify it. You can do so noisily, which means that within that worksheet, you'll see the line of code that was run. So the line of code that resulted in the table you're seeing. You can specify a sheet. You can also specify the cell that the table starts in. So by default, we start in that upper left cell, so cell 1-1 or A1, but you can start elsewhere. So here's that line of code, or that option, sorry, that we added, because this is actually a single line of code, which I've broken up using the triple forward slashes that you see in green here, but this is a single line of code. It's the eTable command, and we've added various options. Title options so far, title styles, note styles, and export so far. We can also manipulate the coefficients and the coefficient statistics that are showing in our table. By default, the eTable command will display all coefficients and their standard errors, so their beta values and their standard errors. And both are formatted to 3 decimal places. Standard errors, as you saw, were encased in parentheses. So we can use this option to keep here to state which coefficients we would like to display in the table. If we'd like to subset, just display the coefficients, a subset of coefficients. We can also use keep to reorder those coefficients. So the order that they appear in the keep command option is the order they will appear in the table. We can also, for the coefficients and the coefficient statistics, we can style those statistics in similar ways to how we styled the title and the footnote. We can adjust the font. We can apply a label of our liking. So we can style the font, the size, color, bold, etc., shading. We can also format the number and how it displays. And so we will work with that as well, and I'll go over that in the next slide. We can also, if we'd like to display the confidence interval of our beta value, we can define the delimiter. So by default, the delimiter is a space, but it's typical to use a comma. So we can specify that. And here are the coefficient statistics that we can display in our table. So we have our beta values, our standard errors, p-values, just going over some of the statistics that we might want to display in a table of our interest, confidence intervals. So we'll first decide what coefficients we are displaying in our table. Here we're just keeping age. So by stating keep age, we will not see the intercept displayed in our table. Alternatively, we could reorder the constant and the age, because the original order was age and then the intercept, but we could transpose those two. We will also add a few statistics to the table. So by default, the beta value is displayed. However, here we are using the option to also display the p-value instead of the standard error value. And the cstat command option must be stated for each coefficient statistic you would like to display. So we see cstat RB, cstat RP. Okay, so let's take a look at that before we talk about styling the coefficients. Okay, so here we have our code where we're just keeping age. So you'll want to keep your eye on the results pane. So here, instead of the person's age and intercept being displayed, we just see person's age. So that's the adjustment we've made to the table. Now, instead of seeing our beta value and the standard error, we'd like to see the beta value and the p-value. So we'll make that change. So now we see the p-value displayed for that beta value instead of the standard error. The change seems to be a bit more subtle, especially since the standard error and the p-value are numerically, essentially numerically identical, but I assure you this is the p-value. But what if we'd like to add confidence intervals, which is typical in certain journals? Here we have our confidence interval for the beta value instead. And as I mentioned, the default delimiter is a space instead of what we would typically use, the comma. So now let's talk about styling our coefficients, right? So how would we like those coefficients to be displayed? And we will style both the beta value and the confidence interval. So again, we're going with Calibri as our font, 12 point, just to remain consistent with our title and our note. And we are formatting the number here. And we could honestly give a mini workshop on formatting numbers, but what this means is that I'm allowing for 7 positions for the number, which I mean, it's kind of, that's not typical. You wouldn't see that, but just for funsies, we're using we're allowing 7 positions, 2 decimal places that is fixed, so it's not floating, and then the C stands for comma. So where applicable, a comma would be applied, and we're using the same format throughout, the same number format throughout. We're doing some of the same things. We're applying some of the same font options to the confidence interval. We're displaying it in Calibri font, size 12, or formatting the number the same way. However, we've also changed the delimiter for the confidence interval from a space to a comma. And now we'll see what that looks like. So we can't see some of the font options on display here without looking at our exported spreadsheet. However, we can see that instead of the space between the lower and upper bound of the confidence interval, we now have a comma, and we also see our number formatting enacted with these 2 rounding to the 2nd decimal place, right, instead of the 3rd. We also see that adjustment has been made. Okay. So next we'll talk about adding additional model statistics. So as a default, the number of observations is displayed in our e-table. However, we might want to display other statistics such as your R-squared value, adjusted R-squared, F statistic, the chi-squared value corresponding to the F statistic. And so by default, we're displaying the number of observations. However, we can add additional statistics or remove the number of observations from our output. We can style these statistics in similar ways to how we've styled other text and statistics previously. Font size, color, whether it's bold, italicized, we can also shade, we can format the number, we can format text. And so we'll see what that looks like here. So here we've added another set of options, right? So our line of code is growing and growing. So again, this is really just one line of code that I've broken up just for the sake of visualization and seeing the options clustered together, really. So it's for visual display more than anything, but we are still displaying our number of observations in. We're displaying the F statistic, our R square, and our adjusted R square. So that's what we're asking Stata to do. Wow. This code, it just expanded significantly here. So we can also add those options, append those options to the stated statistics. So for the number of observations, again, we're going with size 12-point font and Calibri. We're using the same number formatting, just so that we can see whether or not something happened and sort of have a little fun with this. We're adding some shading to the background, light gray, which is not typical when customizing our tables for publication, but why not? Because we can. We're doing the same thing for the F statistics. So again, this, as with the CStat command option, with the MStat command option, we state that option for each statistic we would like to be displayed in the table. We're doing the same thing for R squared, no differences, 12-point font, Calibri, same number formatting. We're shading the background. And here's a mistake, actually. So we have stated that we would like to display our R squared value twice. I wonder if that will show up in the table twice. We'll see if there's some sort of adjustment that's made, what that actually looks like in the table. Sometimes mistakes can be fun. We can see sort of the boundaries or adjustments that a command may or may not make. And then we've requested the adjusted R squared value as well. And so we have formatted or styled these statistics in the same way across the board. Okay, let's see what this looks like. And we'll actually reopen our spreadsheet to see that some of the styling options have been applied, because it's impossible to see some of those options in the results pane in Stata. Okay, so now we see our table has grown. We not only are displaying our number of observations, we are seeing the F statistic, R squared value, the adjusted R squared value. We still have our footnote, our title, our confidence intervals, delimited with a comma. So let's now apply the styling options to our model statistics. Here we see the R squared value is displayed twice. It is only labeled once, which is interesting, but it is displayed twice. We'll fix that later. The other styling options we can't see in our results pane. So let's just quickly open our workbook to see what has happened. So we see the shading now, right? Which is what you could not see by looking at the results in Stata. We do see the background shading in light gray. So our table's looking interesting. We have these chocolate, but not really chocolate. We have a title that's in chocolate. We have a footnote in chocolate. We have the shaded background for our model statistics. We won't leave the table this way, but it's fun for now. Okay, this brings us to displaying the results of regression models side by side. So some of you may have been exposed to the idea of hierarchical regression. So nested models, and oftentimes with hierarchical regression, we'd like to display the results of our models, running our models side by side. And we might want to display other types of models or other sets of models side by side. Maybe we're looking at the same independent variables, but looking at a different dependent variable. There are various purposes for which you would want to display your model results side by side, the estimates side by side. And we can do that using eTable. We can do that using the command option estimates, and then stating the models that we would like to place side by side in the order that we would like to place them. There's some other options as well, which we will play around with. The column header for the results of those models, we can change that. For now, we have it displayed as the dependent variable, hours. We can display the label for the dependent variable, the command we've used, the estimate that is being displayed, or an index. And this is what we'll often see if we're looking at hierarchical regression models. We'll see an index. This is model 1, 2, 3, 4. We'll go with the index for today's purposes. We can either apply or not apply the labels to our variables. to the factor levels for factor variables, and we can also choose to or not to center the results in our cells if we're exporting to Excel. So we'll first, in order to build up to presenting side-by-side models, we need to run additional models. So we will run 3 additional models. We're building on our initial model. So in our initial model, we had the independent variable age. We're adding this variable single, which indicates whether or not an individual is single or married. We will then add work hours, time, their commute time to work, and then in the final model, we'll add distance to work. And we will ask eTable, we'll use this option, this command option, estimates, to display model 1, 2, 3, and 4 side by side. We'll also use the command option column to place an index above the results for each model. So we'll see an index 1, 2, 3, 4 instead of hours, 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 hours. And we'll just, for fun, work with the variable label and the factor label and say, don't present the variable label, just present the, for the independent variables, the variable itself, the variable name itself, and the factor level itself instead of the label for the variable or the factor. So we'll see what that looks like. Okay, let's quietly run our models, which means that the results for those models will not be displayed in our results window. We've also stored the estimates for those models. And now we are going to, our table is going to grow, and we'll see those models displayed based on this line of code side by side. Or sorry, not this line of code, but this chunk of code, because again, this is really a single line of code that has been broken for the sake of display. Okay, it's a bit cut off here, so we'll move, we'll adjust, but here we see model 1, 2, 3, 4. And again, the dependent variable is displayed as the header. So our dependent variable is the same for each model, hours, 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 but we'll change that in a moment. We still see the statistics of interest, the coefficient statistics, the beta value, the confidence intervals. We're still seeing our model statistics of interest here. Still, R squared is repeated twice. We will fix that as well. Okay, let's go back to our code, and we've added this set of command options. We are going to change the column header from the dependent variable to an index, so we'll see that change. And we're also going to display the variable name itself instead of the label. So for person's age, for example, we would see age instead of person's age. And here we have it. The changes have been made. We see our index, 1, 2, 3, 4. Age, single. We also see instead of the label for the factor level 1, we are seeing the raw factor level here. Work hours. We'll reapply the labels because this isn't as satisfying to consume here. So the actual variable names, we like the variable labels, which are great for ease of interpretation and just understanding what we're looking at here, right? So let's remove a few of those options, and we still have our index displayed at the top as a column header, but now we have our variable labels applied. I think using using the variable names is perhaps useful when maybe presenting to colleagues so that they know exactly what variables you're using per se. There are instances where that might be useful, but when publishing our results, the label is what we typically want to go with, or when submitting for homework purposes. We can do a few other things with this table, like adding stars to indicate significant results. There are several options here. The default is to display 1 star for p-values less than 0.05 and 2 stars for p-values less than 0.01, which is the common convention. And these stars are by default attached to the coefficients. But you can use whatever convention you would like. You can specify that convention up to 5 levels. And there are options. You can show these significance levels in increasing order, decreasing order. You can attach the stars to a different statistic. You can also specify a different name. So by default, the naming convention for the p-values is just P, which you'll see stated in the footnote, but you can use a different naming convention, a different delimiter. Typically, the delimiter between the significance levels is a comma. You can use a space or any other character, reformat those numbers. So there are a host of options here. We can specify to show stars or no stars, show the note, star note, or not show the star note. So we'll take advantage of these options here. We're not specifying our own stars for the sake of time, but it's important to know that you can use another convention outside of the default, which you might want to take advantage of. But we are going to show stars and we are going to show the stars note. Let's see what that looks like. So here we have those options added to our line of code. Okay, we now have stars in our table indicating significant beta values, so significant associations. And we have a footnote added to indicate what these stars mean. A single star means this, a double star means that, and the significance levels are delimited with a comma, as I said, is the default. The sort of title used for the p-value by default is p, but we can re-specify that to p-value if we'd like, or something else, depending on what the expectation is for your course or for the style guide for the journal that you're submitting your paper to. Okay, so now in preparation for further customization, we have a few steps left here. We are going to clean up this table a little bit. But first, let's check our Excel spreadsheet. And I'll highlight here that these side-by-side results, I'm exporting to a different spreadsheet. So the single model results, we were exporting to that spreadsheet LM1, and now we're exporting the results of the side-by-side regression to a sheet called side-by-side. So we'll see what that looks like before we clean up the table. And then we'll see what it looks like after we clean up the table and add a few additional features to it. Okay, we still see our footnotes in this burnt orange, also known as chocolate color. Our title, same thing. It is bold. we see stars, we still see our model statistics with the background in light gray. But what if we'd like to make additional adjustments to this table? For example, right now we see that the confidence intervals are on a separate line from our beta values. What if we'd like these statistics to be on the same level with each other? We can do that. There are a few other things that we can do. What if we'd like to add a column header, sort of like a higher, we'll call it a higher order column header to the top of our table so that readers know what this 1, 2, 3, 4 means. It is the model index. We can do that as well. Now that is outside of the scope of eTable because there are boundaries. We won't save this. There are boundaries of the eTable command and the table command, which I mentioned earlier. So what that requires us to do is to engage additional subcommands of the collect system. So for those of you who sort of missed the intro, this eTable command, as well as the table command, which is useful for descriptive statistics, they're built upon this collect system, which collects your results and displays your results. So once we've reached the boundaries of the eTable command and the options that it offers us, we can further apply features via the collect subcommands. And so we'll just take a sneak peek at that because talking about collect as a system would probably require multiple workshops because that system is so robust, but perhaps this will pique your interest in digging into this collect system itself. So here's what we've done so far. So we'll just quick review. We've worked with titles and footnotes. We've exported our table. We've reordered coefficients. We've styled them. We've styled the coefficient statistics. We've styled the model statistics. We've placed regression results side by side. We've played with variable labels and factor labels. We've added stars to indicate significance levels, but we'd like to make some further adjustments to this table. Again, we'll do that through a few collect subcommands. And I'll run this code so that you see it, but again, the collect system, which underlies eTable, it collects the results here. It's collected the results for 4 models, and it collects those results in a set of dimensions. So here you're seeing those dimensions listed and the number of levels for those dimensions. We won't unpack this totally, but this is meaningful. These dimensions and the levels can be further adjusted so that you can further customize your layout, the layout of your table and the display of your table. And so that's what we'll be doing here. We are going to apply a higher order header to the columns, as I said. That higher order header will be model index. So readers know what they're looking at here, what the 1, 2, 3, and 4 mean. We also want to place our coefficient estimate and the confidence intervals for those estimates on the same line. So we'll use collect. You see this command collect here. We'll use collect to create a composite result. And then we'll use collect layout to specify how that composite result is displayed. And so we're not digging into the mechanics here, but I'm just sort of showing you what else can we do here. And then we'll export that updated table, right? Almost gave you a sneak peek at the final table. Oh no. Okay, go back to our code. So we can use this command collect dir, dir, to display our current collection, right? So our current collection, what collect has collected is results from eTable you see here, and there are 262 items in that collection. We can also, as you saw displayed in the PowerPoint presentation, examine the dimensions in this collection. So here are the dimensions, here are the number of levels. So we have some guide for further using the collect system. Okay, so let's assign the model index label to the columns. Let's do that. We've done that. You won't see it here. We will see it when we export the table. We'll create our composite score, or sorry, our composite result. That's run successfully. We'll specify our layout. Here you see, you don't fully see the results of some of this work, but we do see here that the estimate and the confidence interval for that estimate are displayed on the same line, which is what we wanted for sure. We also see the model index. We see that, that column header, that new column header. We'll export this, and we're exporting this to a new spreadsheet called side-by-side update. So now we've done all of this work with one long line of code, which now that we've reduced it a bit and made some adjustments and taken, removed some of the styles that were unnecessary, it doesn't look so long, but one long line of code, another short, so 2, 3, 4, 5 lines of code, and then the export command. Let's take a look at our workbook. And so here we see our results. Model index, the confidence interval next to the estimate itself. We also have removed the repeating R squared value. And let's not save that. Don't save. So we've seen many of those changes made. There were a few changes that we're not seeing there because we removed the, in this line of code, I actually removed the coloring for the title and the footnote. And so there was something going on with the export that I'll have to figure out. It did work earlier, but yeah, this is what the final table actually should look like. So this is what our final table should look like once I fix whatever's going on with the export. So we have now the title and the footnote displayed in black font. The title is still in bold. I removed that additional, this is a footnote, and we remove the background, the light gray background from the model statistics. So this is the table that we want to end with. And so I'll check out that code later before resending that so you all have the proper materials. But we, as I said, let's revisit that actually. So we went from, for those who missed the initial sort of slides, we went from what's on the left side, the standard display of a single model in Stata from the left side to the right side. That's what we're able to do and more. This collect system is really useful because you can create templates that can be reused for future purposes. So I hope that brings us to the end. I hope that this is sort of piqued your interest in eTable and maybe checking out table for your descriptive results and this system of commands called collect. I think we have a couple of minutes. If anyone has questions or wants to revisit any lines of code, I think we have a few minutes to do that.